Good morning. I'm Bill Christie, and today I'm the interlocutor speaking to Matthew Conroy, who is the curator for the LipidMaps structure database. Matt, what brought you into this area?
Well, my background isn't lipids or lipidomics at all, strangely. I'm a protein biochemist. My background is in structural biology of proteins, though always of membrane proteins. I started out in my PhD removing proteins from cell membranes with chloroform methanol, and then moved on through electron microscopy, putting proteins back into artificial membranes in the hope that they formed crystals, and then into crystallography of membrane proteins, which was unsuccessful, as many membrane protein crystallography projects are. And then from there, I moved into database curation of protein data. So I curated the protein data bank for 10 years. And the arrangement where I was is that that was the limit, and beyond that time you couldn't stay. So I was looking for a new job, and curation from a different food group from proteins into lipids came up. So I applied for the job and started in post just before the COVID outbreak last year. So I was in the job for about a week before we locked down, and I haven't left my home since, almost.
The term curator, we think of a dusty museum type of job, but the lipid structure database is anything but static. I gather it's highly dynamic, and you've been introducing new changes and improvements.
It is, and that term curator is a big problem. About a couple of years into my time at PDB, I had a very long, persistent cough and lost a lot of weight at the same time. And I was sufficiently worried to go to the doctor. And when he heard I was a curator, he got utterly fixated with dust allergy. And I had to be incredibly firm with him to say, no, I sit in front of a computer. I am not dusting off artifacts in a museum. But yes, a scientific database should be very dynamic, and we are adding new data almost every day and making changes to move with the times. I mean, there was a paper about 20 years ago about protein structure databases that said just knowing the position of the atoms is of essentially no value at all unless you know something more about it. So unless you know what the molecule does, where it's from, how it behaves. And that's a term called metadata in database curation. So it's not the primary data, but it's lots of information about the data. And in that, the same applies to in lipid maps. Just having the structure of the molecule is of limited value if you don't know anything about what it is. You know, we could all draw a hypothetical made-up lipid, and it would be as valid chemically as any molecule in the database, but we need to know what it is. So one of the key things I've been adding is provenance for where is this lipid from? Where did we curate it from? And where is it found in nature? Now, in an ideal world, we'd also have lots of information about the function of the lipid. However, that's really hard to keep up to date with, particularly with 45,000 lipids. We can't possibly be keeping track of the literature every time someone finds a new or different function for one of them to go back over that. And there's all the controversy about various lipids and what they do as well. So we have to be realistic about what we can do. But I think the most important thing is the provenance. Where did we curate the lipid from? So we're showing that very clearly on the pages. And that enables us as well, if someone says, we think this structure is wrong, we can go back and check. Well, was it drawn wrong in the paper? Has the paper since been retracted? Did I make a mistake converting it across? We can keep track of that information. And crucially, we're adding taxonomy. So what species did we curate this lipid from? I think that's a key thing, particularly as more and more people are doing untargeted lipidomics. Many lipids, of course, are ubiquitous. You'll find them in whatever sample you get your lipidomic data from. But of course, some lipids are remarkably specific. And if you're doing a human lipidomics experiment and you find in the sample a lipid which has been curated from some bizarre deep sea starfish, well, it's possible you'll find it in a human sample. And I guess it depends what the human has been eating. But you should really ask the question, how likely am I to find this lipid in my sample?
So you expect the main users are those working in the lipidomics area?
Yes, I think a huge number of users are working in that field. So they're finding masses and they're querying the database to find what those masses might be. Now, that's an area that's fraught with danger, but that's one of the main uses.
Do you get much feedback from users?
Very surprisingly little, actually, which either means they're very happy with the data that's in there, or they can't find the feedback form, one of the two. But there was a paper a while back looking at a lipidomics study of skin, and you look down the table in the paper of the lipids they'd found on human skin, and one of them was a laterane lipid, which is particular to organelles of some strange anaerobic bacterium that metabolizes ammonia via hydrazine, which is rocket fuel. And that's extremely unlikely to be found on human skin, unless the human, I guess, has been swimming in some strange anaerobic bog immediately before the sample. And one of them was a deuterated lipid, and you definitely wouldn't be finding that. That's just the standard in the database.
The problem, I guess, is that people assume that computers are infallible. I've noticed that in GCMS of fatty acids as well, that people rely on the database that's supplied with the instrument without understanding the nature of mass spectrometry, even mind the samples they're working on.
Yeah, I think that's a big problem, and not only in lipidomics, I think a big problem throughout bioinformatics. There is a tendency to assume that the computer is right, and what everyone really wants is the big button in the middle of the screen that says, tell me my results, give me my answer, solve my PhD problem for me, write my thesis. And of course, that's not the case at all. There's no bioinformatics database or tool that really gives you an answer. I think all of them generate hypotheses for you to test either experimentally or look at the results you've got and think, is this plausible? And if the result you've got is extremely surprising, then there are two options. One is you found some amazingly new novel science, and you should wait at the end of the phone come autumn for someone from Sweden to bring you up for the Nobel Prize announcement, or you're wrong. And it's far more likely that you're wrong than you've won the next Nobel Prize.
Do you have any longer term plans for the database?
There are, yes, various plans. Having added or ongoing adding the taxonomy information, we need to integrate that somehow into the search system so that you can filter on lipids curated from only mammals or curated only from deep sea starfish, filter out the ones from strange organisms. And that's a problem that we will have to tackle down the line. That's implementing search systems of the data is a far more challenging area than just adding the data. And we're looking at reactions as well. We'd like to add information on what biochemical reactions a particular lipid takes part in, which is an ongoing project, and that's information that we'll add to the pages over time, but I don't have a timeline for that at the moment. Thanks, Bill, and we hope it's useful, and we'd appreciate a lot of feedback from all of our users to tell us what they like, what they don't like, and how we could improve the database. And if people want to contact us, in the About Us section, the tab at the top of the Lipid Maps web pages, there's a Contact Us form where people can write in their suggestions, their feedback, and we'll be very happy to receive that.